In this video, we'll explore how to solve inequalities. Now, when we go to solve an inequality, we're going to start by solving it like we would a typical equation. The big difference is actually how we report the solution. Because we have that inequality, the answer is always going to be everything that's greater than or less than that specific value. When we solve the problem, just remember if you have to divide by a negative number to remove it from the variable, that you flip that inequality around. Whenever you read your inequality, always read it from the perspective of your variable. And when we actually give the solution to our inequality, we're going to state it in three different ways. We're going to write it as x is greater than or less than the number. Then we're going to give it interval notation, and then we're going to graph it. Now, with the interval notation, we have to pay attention to whether it's greater than or less than, but also whether it's got the equals to component. If it's greater than or less than, we're going to be using parentheses. If it's got the equal to component, it has a bracket by that number. Now, when we say less than the number, it's everything that is less than that. So that's why we use the symbol negative infinity up to a right here. And you can never actually get to negative infinity, so the infinity symbol always has a parenthesis, and it goes up to a. Same thing when we say less than or equal to, it's a parenthesis on the negative infinity, but it's a bracket on the a because that equals to. That also changes whether our dot is hollow when it's less than, and it's solid when it's got the equals to. When it's greater than a, you see we're going to go from a and everything bigger. So it goes on for infinity. So we use positive infinity. And the equals to, we have the bracket on a and goes up to positive infinity. Again, solid dot for the equals to, hollow dot if it's just greater than. If you see a compound inequality where you have that x is between two numbers, that means you're going to put dots on each number and then shade everything in between. And your interval notation will just be the two numbers. Hence down here at the bottom, this is a is less than x is less than b. That's going from a to b, and we use parentheses because both of these are less than symbols. Now remember, we're always trying to read from the perspective of x. So always start when you say that x is less than or x is greater than. And sometimes you may have to rethink about how you read the inequality. So if we solve this inequality, we have 5x plus 8 is greater than 9x minus 12. So we're going to solve it like any equation. I can add 12 to both sides and then subtract 5 from both sides. And I have 20 is greater than 4x, so I divide by 4. Now the key here is reading this from the perspective of x. And when I read that, that is x is less than 5, because the inequality is opening away from the x. So that means my solutions that make this true are going to be everything that's less than 5. So from negative infinity to 5. And again, I'm using parentheses because it's the less than symbol. When I shade it, it's going to be a hollow dot on 5, and I shade to the left because it's less than x. Here I have a compound inequality. When I have a compound inequality, I'm going to be looking at two different inequalities, but it's the and symbol. So I have that 9 is less than or equal to 3x plus 4, but I also have that 3x plus 4 is less than 16. So I solve each of these inequalities. So I'm going to subtract 4 from both sides, divide by 3. So that gives me a fraction, and that's okay, 5/3, which is 1 2/3. And I want to make sure if I have a fraction that I make sure I make the individual marks on the graph to represent the thirds. Here I'm going to solve, subtract 4, divide by 3, and that gives me 4. So x is greater than or equal to 1 2/3, and it's less than 4. And that's how I would write my compound inequality. And in interval notation, I would just put the two numbers. This one is a bracket because of the equals to, and this is parentheses because it's just the less than. So I shade that. I put a solid dot on 1 2/3. I put a hollow dot on 4. And if you look at the way I graphed this, I have the large tick marks for the whole numbers, but then my interior tick marks mark off by thirds. 1/3, 2/3, 2, 2 and 1/3, 2 and 2/3, 3, so that you can see exactly where that number would fall on a graph. Now, last thing to be helpful here is the idea of the reciprocal properties of inequalities. Sometimes we get where we have a fraction will be less than or greater than 0. Well, we can't really solve that for 0 because if I multiply both sides by a, I get 1 is greater than 0, and that's always true. So to really have to solve this, I take that denominator and set it as less than or greater than 0, whichever the inequality already is. So say I have this problem. 1 over 3 minus 4x is greater than 0. I can't just solve it as it is, but I can just set the denominator equal or greater than 0 because this problem is greater than 0. That I can solve. I'm going to subtract 3 from both sides, and then I'm going to divide by -4. Now here I'm dividing by a negative, so I need to remember to flip that inequality around, so now it's x is less than, well, -3 over -4 gives me positive 3/4. So I have that would be negative infinity to 3/4. Both have parentheses because it's just the less than symbol. And then I'm going to be shading a hollow dot on 3/4 into the left. And again, you can see large tick marks for my whole numbers, small tick marks to represent, in this case, the fourths. 1/4, 2/4, 3/4, and then 4/4 is 1.